Hello everyone, welcome to another stream. How are we all doing? Oh, right, let's try and remember exactly where we were. So just double checking that's all working okay. That seems like it. Hello, hello, hello. Good, good. Right. So last stream that we did, we were trying to get these we changed it such that there's 3 different types of materials. There's geometry materials, there's detail materials, and there's blend materials. Geometry materials like will be the initial ones that we ray march into, and detail materials allow you to sort of change the geometry by spawning loads of little spheres, bounding spheres on it. And blend materials just allow you to change the color, basically, or the material, by blending another one in. So we got the geometry materials working, which is this brick one. So geometry materials typically just work for a good, I can leave this running. This is amazing. I thought it wasn't running for a second, so I'm glad that's running. So geometry materials allow you to take a cube, for instance, and then ray march into it and basically change the geometry, right? Then a blend material would be like one of these things. So essentially, it will just spawn a bunch of spheres inside of a grid. So there'll be a grid which is laid out across the volume, essentially, of the immaterial space, -1 to 1. And yes, it's in 3D. And these bounding spheres will be offset inside the grid. And there's 4 of them in each grid cell. And you basically ray trace the grid cell. If you hit the grid cell, yeah, you ray trace the grid cell. You're supposed to hit the grid cell and then ray trace each of the 4 spheres, see if you hit them. And then if you don't hit them, you basically ray trace to the next grid cell and repeat. But if you do hit one of these, you will then check to see if the center position of the bounding sphere has a radius that's less than, sorry, has a distance which is less than the radius. And if it does, then we will allow it to sort of go in further and to try and ray trace this thing which is inside the bounding sphere. And it could be like a volume of moss, for instance, right? Or it could be some grass or something like this. We've got to play around with it, but that's the basic idea. Or it could be like a stone, right? Something like that. And it's just for adding more detail on top of something which is already ray marched. That's the plan for it. But yeah, there's things we want to tweak around, but it should be quite powerful. I'm not sure we're going to do multiple detail materials. We might just do one. We'll see. But if you could do multiple, that'd be also pretty powerful. So what we're trying to get working right now is simply just get a debug drawer of the bounding spheres, which are randomly placed down on the surfaces of these objects. So, so we've got detail material for moss, which is the one that we're testing out. We've got one geometry for brick and another one called blend, which is called raw. This just allows you to basically blend on top some material properties, like maybe different color or something like that. Just blend it on top. So Yeah, ignore that. Shade Moss. Right, where's the it's called Rain March, isn't it? I think. Right. Well, you should do a quick prayer. Let me just quickly pray. Dear Lord, thank you for this day. Thank you for everything you provided for us. Thank you for the food we eat. Thank you for our health. Thank you for our families, the fact they're still alive. And thank you for the chance for everyone who's still alive still to be saved. Thank you for the peace in our lands. Not everyone has peace in their lands currently. And thank you for the fact that we're still able to exercise our religion freely. In other places, people are persecuted and things like this. It goes on all around the world. So we just thank you for that. Thank you, Lord. Um, I pray that you help me have a good stream today, successful stream, achieve what I can set out. Give me the energy to do a full stream, and pray that each and every one of these viewers will have a good time as well, and get something from this stream. Also pray that each and every one of these viewers gets to know you, Christ, gets to know you, that you are real, that there's evidence for your death, burial, and your resurrection. And pray that they come and just surrender their lives to you, Lord, and receive their free gift of faith, salvation, and the Holy Spirit, and many more gifts which you have to offer them. Thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. Cool. So the rain march is basically just gonna rain march into the brick. So this is what's known as the geometry material. Then after I've done this detail one, this is one we're still going to try and get to work. So as I explained before, there's simply just a grid of there's just a grid, and inside each grid cell there's like 4 spheres which are randomly offset, and that's all this code is doing, right? So we iterate through each cell, and we're basically ray tracing. We're doing a reverse ABB to basically step through the grid cell, and when we go outside we should break, and when we go inside of a grid cell we just go over 4 random spheres, right? Get a random vector 4 and get a random offset and a random radius from that vector 4, and do a reverse sphere inside that grid cell. That's all it's doing. That's what we're trying to do, but it's not working at the moment. So we're just going to try and get 4 spheres. We're just going to be able to try and get, a bunch of spheres being rendered on here. That's the plan. And then we can progress further by rejecting ones which are less than radius away or something like that. And yeah, it's going to be cool. So rejecting ones which are further than the radius away from the surface. Okay. So we've got a printout going. That could probably be helpful. So I just want to try on one of these guys. No, you've got a print 1. And that's just going to give you this V scale value. I think we're getting some NANs or something like that. Forget. Maybe I fixed some of it. So 1 is just the scale, so it's 1 in everything. That's fine. Then, oh yeah, what was happening is we was getting a value which is bigger than 1.0. So you notice the G with a 2 on it as a 1.2. And because of that, I think what ends up happening is, this isn't very nice. Yeah, end up getting rejected, something like that. So we're checking the detail UV here, style center position. Right, so right, 4 is cell center position. That guy. Right, Seldim, inverse Seldim, interesting. Okay, so it seems like this is... Right, we need to see how big a cell dimension is. I think we should move this up here. Probably comment this one out. Right, so we've got a 0.6. Yeah, it's quite big. So the space is at -1 to 1, right? So it's like a quarter of the size of the cell sizes are quite big. So effectively, when we're doing this maths to figure out what's the center of the cell, it is ending up going to like 1.2 on the Y for some reason from the 3%, 0.99. Yeah. So it's okay. I think we need to round down at some point, or have the direction sort of help bias where it's going. Yeah. So all this little function does is just take the UV, divide it by the Seldim, and then add 0.5. So you're basically in cell space at this point, right? You're in grid space. After that, and then you're just saying, right, in the middle of the grid cell, divide it in half, and then round it to the nearest. Hang on a minute, why is there a round in there? And then times it by... Yeah, the round should be here. Then you do the plus 0.5. Then, okay. I don't think that's going to help anything, but yeah, so it's changed it now. So the G4 4 printout value in the terminal, on the Y it's got a 1.5 instead of a 1.2 now. Okay, so change something, but at 1.5 is still out of spaces because it's -1 to 1 space, isn't it? So right, so that's interesting. So yeah. So because it's a round, it's going to end up rounding upward, isn't it? So say if you've got like a 1 or something like that. Yeah, so what's happening if we draw it? We've got a grid. So rather than being... So 0.5 would be a quarter, right? But we've got like 0.6, so it's a little bit bigger than a quarter, meaning that when it's a half, it's like a little bit more than a half, isn't it? Yeah. And then let's just say that. Yeah. Then when it's like a oh, what's the way of drawing it which is better? So let's draw it as an actual grid. So 1, 2, 3. And the next one will just be slightly out, wouldn't it? Right? So when we have our array, which sort of starts in this grid cell here, we're doing that maths. And because it's doing like a round up, it's ending up like up here or something like that. It's doing a round, whereas we wanted to make it. Yeah, ignore this grid cell here, by the way. This is an old grid cell. Ignore this one. We're talking about this new grid that we just made on top of it. So because we've rounded out up to here, maybe that's okay. Then what's the code doing then? Yeah, I think that's fine. It's supposed to be doing that. Yeah, it's supposed to be doing that, so it's supposed to start there. Oh no, but which way should it be rounding? That's the thing, isn't it? So like, right, but the seldom is 0.6. So why then is the center position 1.5? The detail UV would have been this one here. That'd have been like divide by, then round it. Oh, rounds it to the nearest. Yeah, I'm interested to see what that means. Let's print this out. We've got a compiler. UV would be detail UV. All right, here we go. So 3 will be detail UV, so it's 2. Plus 0.5 times by 0.6. Is that really gonna... Well then... Fair enough. Is it really that... It feels a bit off. Ah, crap, what's this? Fair play, so it actually fit... Right. Who knew? Right, so that is correct. Okay, so what's the next thing to check? So we've got the so the detail UV. How does it end up being at 1.5? Where is it? Scale E1. Oh no, sorry. Okay, so center position at 1.5. Okay. So hmm. So gonna crack a window open this bit. And it's warm these days. Okay, so I'm thinking that there's something to do with the grid cell. Yeah, I just want to double check to see if our position is actually right, the center position. So, yeah, so if we got rid of the 0.5 add there, that would be... Oh, it's doing it a whole bunch of times. Interesting. At that point. 2, 1.2, 1.2, 1.2. So adding the offset of 0.5, why is it adding... Yeah, so if you've got a cell dimension of 0.6, don't know how we ended up with that, but we got one. Then that would mean you get basically 3 and a bit. 3 nearly 4 cells, or you'll get 4 cells that fit inside of the space. So, yeah, how do we fit those ones which are not perfect integers at that point? Do you where do you align it? Do you align it in the bottom left corner, or do you sort of like make it? Or do you just say the grid has to Yes, I think what we could do is make it such that this grid has to be right. So where's denseness? So it's a sort of lerp between. Mm. Yes, the grid could be basically aligned to the center and it could be offset in certain ways. Or it could just be literally deciding how many of these if you did that, denseness would be smooth as you moved it. And that's probably what you want. So we probably might have to get the maths right for that. Yeah, so I think we've got to just draw it out and see what we can do. So, right, let's just say you have a box, right? This is let's just say we've got a cube, and this is the space of the material -1, +1. Now, we have our geometry material, so it could just be a bunch of like bricks or whatever that it's ray traced into and all this blah, 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 but let's ignore that for a minute. So with the detail materials, basically we just form a grid down. Okay, and then inside each grid cell, we spawn 4 spheres, and we will basically ray trace against those and then see if the ones that we hit, do they hit the surface basically, or are they near the surface? We check, yeah. So We just got to try and figure out how we lay down a grid based on some denseness parameter. Oh, there's one of these people. So essentially, if we had but a 0.6 size of a like, shouldn't it just be perfectly divisible by yeah, shouldn't it just perfectly fit in there? Why did it end up as 0.6? I think that's the problem we're gonna look into. So denseness, yeah, based on that sort of max sphere radius. Right, so it's at least that big. Okay. So but we've got to make sure it's probably rounded to the nearest multiple of mm, yeah. So I think you're gonna have to yeah, so say if you have like let's just say you have a 2x2 grid, right? So it's quite easy to see this. So if you were to try and like smoothly go from a 2x2 to a 3x3 grid, then effectively all you would be doing is shrinking the 2x2 such that it would be doing something like this, right? But then realistically, what you have then is actually, as soon as you go past the 2x2, you've actually technically got a 3x3, but it just goes off the page, right? At that point, right? Or you've got a 4x4. Hang on a minute. You've got 4x4 at that point. Okay, I see what's going on. Yep. So this is probably okay. It's just you've got to align the grids at the right. Yeah. Yeah, so the cell's maximum half dimensions is 1, and they'll get you 2x2. No, they'll just get you a 1. It's just a massive 1, isn't it? Yeah, so probably your minimum is going to be, or 0.5 is a half. Sorry, the maximum number is 0.5, so it's a half. And then, okay. So we've got to really have this anchored at the center point, I think is the way to go. So when we're calculating when we go from UV space into a cell, we really have to be accounting for that, I think. So that would mean yeah, this alone is just going to make it anchored to probably, well, it is -1 to 1, isn't it? So I think that's already doing it. Yeah. So then, yeah, that should already be doing it. So your UV is sitting like right on the edge. So you got the eye here, it's coming down. Your UV is going to be like detail UV is going to start here. Then, so that would mean the center position of this cell, it is going to be up here, right? That is right to have the center position up here. Now, okay. So it's starting to make sense. But what is 1.5? Can we... So that would then mean the 0.6 in size, meaning the 0.6 plus another 0.6, which would be 1.2, then plus a half, which will get you, to a 1.5. Okay. Yes, that maths checks out. Good, good, good. So then we do array. Right, this is working out okay, I think. Yep. So we can ignore these ones for now. Maybe part of the problem, we'll see. Yeah, so the basic idea is, so now we'll do another ray versus ABB from the detail UV from the cell center position. And we want to be getting the far hit. Oh, right, I see. So array going toward the detail UV from the cell center position. Right, so what is the T value at this point? What is, as you would call it, the far hit, right? Because there's a near on X and a far on Y. So, -1. Not very nice. Why are you getting a -1 for, eh? I swear that's the right way to go. Let me just double check my other ray tracing codes. That'll be in scene. Hang on a minute. It's called debug 3D, isn't it? Or draw 3D. Yeah, one of these guys. Yeah, ray origin in wall space minus center position. The detail UV is the ray origin at that point. So the ray direction should be correct as well. Let's print out both the X and the Y. What does it get? They're both -1s. Does that mean we're inside the shape? No, because you should get the far which is positive, but the X which is negative if you're inside the shape. But we're not getting that. How strange. Let's print out the this value here. So our half dim should be 0.3. So what we should be seeing is all values which are less than 0.3. That's supposed to be in the 5 printout G5. Oh, they are sort of bigger than that. A distance away. So G3 and 4 are the detail UV. Yeah, it seems to be right. Wonder what this means. What's the ray direction? So ray direction is G6. So it's pointing kind of downward. Yep. Hmm. Yeah. You know what? Maybe this is a full dimension. Right, I think we get more printouts now. I think. Yeah, we are. So this... I don't know if it's a full... Yeah, my maths might be a little bit off. Let me see. So the cell... Yeah, you definitely want a full cell for this one. So the ray... I thought it was a half dims that went into here, that's why I labeled it half dims, but I don't know if it is. How could I check? Let's double check. So do this. There's got some ray intersection functions which I got my box one from. So what I was thinking, let's look at his box one for a minute. Where is the box? Oh, I have the box. Yeah, center origin is supposed to mention must be half size, right? Because it's aligned. Let's change this a bit. It's a bit too much, this one. If there's another sample somewhere. Right. So Yeah, that's by doing it based on the corners approach, isn't it? So the one... Yes, the K being... Yeah. So... Yeah, it should be the half size. So... Yeah, no, that is right. That is right. So... The point is, though, is my... Yeah, this is not 0.3 away, is it? It's more than that. I'm in the wrong box at this point. It's in the wrong cell. So why have you put me in the wrong cell? Like, so 0.6, yeah, this should be 1.2. So, what's going on here? Yeah, 1.2 is what we want now, but then... Oh yeah, we should probably do a floor than a plus, not a round. That's the problem. Oh. Right, is the stream still going? We're still here. GPU didn't like it. So I think... I'm not sure what we did actually. Anyway, let's see if we can run it again. Maybe that was just a hot reload thing. No. Okay, so clearly we're doing too many iterations here, and that's completely okay. We're just going to do one iteration. And let's just test it out, okay? Right, so made some progress, I think. Let's verify the numbers. So the numbers we're getting are... Yeah. So 0.4, this is the cell center position, is actually at 0.9. So that would have been 0.6 plus a 0.3, right? So 0.6 is the whole cell size, 0.3 is half. Perfect. So then when we do our ray verse, so we are getting some sort of different colors here. This lets me think that it is kind of working. There's some things which... Something is going on. So if your mouse is at... yeah, so 5 would be the offset. We don't need these actually. It was looking at... We wanted to know what the BH was, so the box hit. So G6 is negative 0.1 and then a positive 0.08. So the first one, the negative one, is the x value, which is the near, and that's going backwards as we would expect, and y is the far going. Hey there, Sir Cellophane. Welcome, sir. How are you? How's things been? Hope you had a good Easter. Yeah, so we should be advancing along that ray. I don't know why we're not. 0.8. Oh yeah, because you're right near the cell. Interesting. So we should advance. So let's do a second time. So if cell I is equal to 1, we can break. That'll then be, I would like to see what the next 3 would be. Advancement. Right, so we've got, essentially, it's very horrible, but anyway, 1 and 2, these guys bridge a new, the next frame, if you will. And so what we'll see is multiple 3s, 4s, and 6s being printed out. So we should see 2 of them. The first set of 3, so the 4 would mean the detail UV. Is that right? No. That's the cell center position. So that should change, but I don't think it has. So the 3 would mean the detail UV. Right, so it hasn't moved to the next cell, which kind of sucks. Need to figure out why is that. Yeah. Yeah, Easter was good. Yeah, it wasn't bad, yeah. Yeah, not bad. Spent my time with family and church as well. Very relaxing. Just was super tired today for some reason. Um, yeah, you know how holidays work, you know. You come back from work after a holiday, it's like you need a holiday for your holiday. But yeah, it was quite cool. It was nice and sunny. You know, got out, sat in the sun as well. So took my bike, my boy out on his bike, and he liked that. So yeah, it was good. Really looking forward to the summer now. Ooh. So imagine what's happening now is the grids are a bit off, maybe. See, I do have like a debug drawing thing, so we could debug draw these grids, and that would really help massively, I think, but we'd have to write the code, but I think we're not too far off. Um, right, so that's got a far of 0.7, if you will, is that right? Or 0.1. So that will advance it a bit. That's for the Z. And oh no, that did move to the next grid cell. It did. No, that's really good. It moved to the next grid cell on the Z axis. That's cool. So it is doing it. Yeah, so I think sometimes you can get caught in an infinite loop. So what you need to do is marginally nudge this by some small amount, right? So you need to like basically multiply this by 1.00001. Right, just make it a little bit more. Something like that, yeah, I think so. Whatever the epsilon is. So you don't get an infinite loop. So if I keep boosting that up, hit the crash. No. Oh, that's interesting. I wonder if there's anything to do with this code here, not gonna lie. Maybe not. Is WebAssembly still a thing? Just random question. Yeah, it is. People are doing it. You know, there's some yeah, WebAssembly is still a thing. You know, it's still a thing. You know, there's Web GPU as well, which people try and target as well with WebAssembly. And it's not that amazing. But, you know, some people like the idea of just being able to give someone a link. No installations, they can access something that they've made. Right, so I guess it does have its benefits like that, but if you're trying to make an application, you're trying to give someone where, you know, you want to sell them a product, doing it on the web is probably not the best idea, but if it's something that you want to freely make available for people, it's got some benefits there, I guess. I think the thing that made it a bit weird is WebAssembly doesn't support virtual memory, even though like every architecture that it runs on supports virtual memory. It would be cool if you could have virtual memory rather than that sort of growing linear allocation thing that they did. Very bizarre. No, it doesn't support compiling to a web app. I don't think it makes any sense for me because I probably want to like yeah, I probably want to just target the operating systems directly that it would want to run on. And probably also the application will be sold as well, and I don't think selling web applications really works too well. I don't know. Unless you put it behind some server DRM thing. Right, has it got the same issue? Right, so I think this does keep stepping. Let me just change get rid of these box hit prints and this here. So we should see a bunch of threes, and the threes just keep on stepping, right? Yeah, they change. That's good. So the one that made an infinite... No. Oh, it is working good. Yeah. Step, step, step. Lovely. Wait. Yeah, that's good, that's good. I like it. So this is the thing which is causing the problem. Okay, that's good then. Progress. Yeah, so in my engine we do use, we're an abstraction of the virtual memory. you know, virtual alloc and all that. And it's kind of cool and helpful. Yeah. I think WebAssembly as well, isn't it limited to 4 gigabytes unless you do some. Yeah, it's fundamentally limited to 4 gigabytes of linear memory in its standard widely used 32-bit mode. Yep. But I think there is a 64-bit mode as well. It is adopting a Memory 64 proposal, right? So it's a proposal. It might have shipped though, because it says 2024, 2025. And we're in 2026. Yeah, there was this thing for a long while. Yeah. So what could be the problem here? So we definitely go. So it must have landed in one of these, right? Surely. You must have hit one of these. Then what? So I reckon what we can do is print out just a bunch of 4s. And this would just be like a group of parameters. You know, maybe we can say, right, here's the vec4 of the offset with the radius. Something like that. Then what we then we can comment these guys out and see what we get. Right. So there are a bunch of 0.1s on the radius for some reason. There's no variability, which definitely sucks. Oh, that's because the min-max radius is basically the same. Gotcha. Right, so right, let's do a min radius full range. There we go, they're sort of changing now. Nice. So you're working on maths library, lots of things, making lots of things parallelizable, if that's even a word. Yeah, I'm not sure if it's like it would be probably like proper English maybe, but like we typically do that anyways, stick on the ables, you know, parallelizable. You know, one of my favorite suffixes is ness, but you can also do like stick an I in there, make it, you know, so say if you have like a like squeeziness rather than just squeeze or squeeze. Yeah, lots of fun. Yeah, SIMD friendly, very cool. So yes, you're talking about parallelizable in terms of taking advantage of SIMD. Nice. You so what you're saying is you're gonna say your vec4, right? Your 32 float times 4, whatever. When you do like a v times something, it's going to use SIMD instructions. Is that what you're saying? Squishiness. Yeah, I guess it's squishiness. Yep. You always have to have parameters named that. Makes programming all the fun. Yeah, squashiness. Yeah. It's amazing. Custom trig. All right, yeah. So, your own sign functions and that, yeah. Because then it's gonna be cross-platform, isn't it? And cross-platform determinism. Is that what you're going for? I guess. Right, so it looks like we're getting, can I break this at like, so like, or I can just do one, isn't it? Obviously. Right, here we go. So, oh, hang on a minute. Somebody didn't put an if statement around this, so it's just printed out for every single pixel on the screen, which is obviously too much work. Okay, so clearly there's no hits. Oh, we got a few hits there. That's amazing. But not really. Right, some. Oh, interesting. Some don't even get any hits. I guess that's what you want, isn't it? Right. Yeah, so if we get a hit, this code was basically, hey, break out such that we can like color it and stuff like that, right? That's the basic idea. So, um, right. Yeah, so what we want to know is like, did we hit a detail material or did we hit the geometry material? I think this is where the bug is happening, right? So what I want to try and do, so this is quite cool. I like it. Plus equal the near VT and then exit, basically. That's all that's trying to do. So why, right, so before we save, we want to know which one we hit. So after the ray march, maybe in the shading structure, we want to say like, which material did we hit? Was it the geometry or the detail? Let's say. Awesome. Yeah, I was thinking about doing some of that stuff as well at some point, maybe, because it's very powerful when you have that. Yes, in this shade, we want to basically either shade with the brick or shade with the detail. Yeah, so maybe we could do multiple different detail materials. That would kind of be nice as well, but then we'll need more layers. So there's that. Anyways, let's just get one working. We can always tweak it around. So in the shading structure is the best place to store it. Let's just add a U32 and we'll call it we'll just call it material layer hit index, if you will, right? It's super generalized and it's only going to be 0 or 1, but there we go. So at this point, you would have hit shading dot this thing equals 0, but then if we go here, turns out you'd have hit the sphere. So when you do the shade, you can now do if this equals 0, else And then we can just do a really stupid simple shade. So this would say sampled material. Where can I get me a good... Here we go. So we just want to output some probably like gray sphere or something like that. So just return S. So diffuse, let's just make it 0.5. Specular. So yeah, there was a thing for this. Sampled, set color, non-metal, S, vec3 0.5. So that'll do your diffuse and specular. Emissive, we don't care, we can make that 0. Gloss, we don't really care. Make it rough, and then 1 on the AO. Alright, so let's try that. Amazing. So we're seeing spheres now. And it's stupid slow. Because we're probably trying to print out so much. Alright, so this is great. We're seeing progress. So here we go. Just leave that for now. Alright, so apparently it's running, but it's stupidly slow. What have we done? Oh, we're still here. Okay, so is it generally that like 4 of these make it like stupidly slow, or like is it something else? Like, so let's just make it 1. One sphere per. Right, that performance seems to be quite reasonable. I think it was kind of looking about that anyway, the scene shade. Oh, yeah, I got some bugs. When you have the profile open, try and resize the window, it doesn't like it. There's stuff to do in my printing which is a bit busted because I've got hotcode reload going and oh no. No, it's something different, ignore me. Interesting, okay, so that's there. So let's up this by 2. And the performance is a little bit or worse, that's fine. Let's do 3. And the performance is stupidly more worse now. Why? Why? But why? So we clearly saw a difference, but why is this making it 3 more? Like, we're doing a thing where we say min with so this doesn't get unrolled, right? But then surely it should allow for more early outs at this point. Right, that's the whole... Yeah, the way some of these are cut off is a bit weird, and you're seeing a sort of a grid as well. All things to fix, that's for sure. Yeah, by changing the number here, it is... Oh, it changes the seed, doesn't it? That's why. Hmm. Hmm. Oh, well, I could add in one more. Does it like... I got a theory. Could it just be allocating just enough more registers such that it's like spilling them or something dumb like that? Or it's causing... And this stuff we can't really tell without a vendor specific tool. Right, let's just carry on with 2 and we'll see how far we get. But I'm hoping to make that number 4. Right, so what we're seeing now is we are seeing spheres, which is what we want. But one, we don't know where they are. We are probably hitting some which are... Oh yeah, that's what we want to do, isn't it? So what we would like to do is know which one is closest. Is it the T from the geometry, or is it the T from the detail, the spheres that we're trying to spawn on the surface? Now, we haven't done a check if they're on the surface or not. That still needs to come. But we just need to get there slowly. So the next thing would be like, hey, is T... what we're trying to say is, have we got a hit? I think we'll say bool hit equal false. We can make this a bit better in a bit, but then we'll say, you know what? T equal infinity. Cool. So if T is inf, if it's not, then v dot t is equal t and this. So now we also want to say, right, if this t is less than v dot t, then use that one. Right, it turns out none of them are kind of like on the surface of the thing, which kind of sucks. You do kind of start seeing the grid now, though. So maybe it does, for some of them, it's weird. Seeing this sort of grid now. So if I were to get rid of this, yeah. So it is kind of doing it for some pixels, which is a bit weird on the grid border, if you will. So that's probably because it exits at a max thing. I would be... So another thing that might do it is like... Oh crap. It's how we exit though, isn't it? Yeah, we might as well do a Boolean. Like, oh, have we found it here? I don't know. Yeah, let's try it out. So Boolean. So has hit equal false. And does not hit, okay? So this one would just break. If we have hit. So has hit equal true. Right, that's got rid of the artifacts. So what's happening there is actually we are getting some cases where if you're on the grid, if you happen to be on the pixels which kind of exactly align with the grid, it's sort of doing an infinite you're basically hitting max iteration here, which is actually really bad, and this is probably where some of the performance could have been going. So there's some, it just gets stuck basically, and that's probably on the entry point. So you probably want to allow it to move off the grid somehow. So yeah, you probably want to nudge, do a lovely little nudge at some point along the direction. So where's the UV? Yeah, so if we were to undo that quickly, so you can do it. Right, we'll just undo it. So I think what we actually want to be doing is just offer it a nudge as well. And that gets rid of it. Okay. So yeah, that gets rid of the infinite loop. I wonder what else you could do. You could make it such that this is a max 0.0001. Um, oh, they're out of sync. Right. So bh.y, you can just call this like far basically. Box hit.y. Yeah. So, you know, this assumes far is never. So box hit.y is never -1. Right. So, you know, and so detail UV is always inside the grid cell. Because if not, it's just gonna, yeah, that's fine. Right, so that's sorted out that problem. So I wonder now if we increase that to 3, does that like make the performance like super bad? Again. No, it doesn't, you see? So 4. Amazing. So yeah, it's made because what was happening is this was at like 70 milliseconds. Not saying 4 milliseconds is good either, but 70 is like terrible. And that was happening because of this infinite kind of loop that was going on, and therefore was maxing out at like grid cells squared, wasn't it? What was it? I thought I did it in the end. Yeah, this thing, whatever that was. So it was just staying in the same space and not exiting early enough. Okay. So what are we trying to do now? Um, right. So why aren't we hitting? It would be cool if we can see like a sphere on one of these, but we're not. It's like really bad. Yeah. Like if we get rid of this, you'll see enough, right? Oh. How bizarre. What happened to these things? It could be this thing again. If we made it such that it was a max between. Oh, that was extremely slow performance. I think it was getting a -1 at some point. Yeah, maybe the stepping code is a bit off. Um, so when we're doing array versus the grid cell that we're currently in, we're trying to step to like the edge of that box and then just go a little bit past it. So I guess you can get, yeah. Hmm. You know, it is going to be doing this. I wonder if we should do the isHit thing again. That might be what we want to do. Then advance. There we go. Right, that's looking better. Although you're getting a bunch of these very fizzy looking spheres for some reason still. Probably a different problem. But yeah. So we did a V and V and T is less than VT. Right, so we are getting some which are on the surface. You can see this one is on the surface here, which is, sorry. Yeah, I wonder if that's how we can just test if they're on this. Yeah. Yeah, we'll still need to do a distance check. Yeah, so this to make this optimized, basically what we'll do is when we're going through these grid cells, right, if VT, yes, if the T value, hang on a minute, can I get rid of that? Yes, so if the T value goes greater than VT, then you basically just stop going through the grid, and that'll be a massive thing for performance. Yes, if T is ever greater than the geometry hit that we got before this, then we can just break out of here. And that will... Cool. Slightly different results though, which is a bit concerning. If T plus sphere hit near is less than the brick hit T, then accept this. I guess you'll just call that new T or hit T. Right, there we go. That's fixed it. Cool. Right, so that should help with performance such that we're not just continuing down through the grids and ray tracing against more spheres when we've already gone past the surface of the geometry. Okay, that's very good. Yeah, it's really helped with the performance there. It's 2.7 milliseconds instead of 4, which it was before, right? So it's still not looking great. Like, we're seeing the spheres, that's cool, but things are not really looking exactly how we expect. So we're seeing half done spheres in ways. It's very bizarre. So if we get open the image viewer, let's pop into here. We can get more of a close-up. Bit weird. These are, you know, this one is probably on the the outside of the sphere, the box, I reckon. So that's probably the reason why we're seeing it cut off, is because it's at the plane, the edge, the face of the box is kind of off. That's my guess. So we can test that by printing out the coordinates. And that's what I reckon this sort of crescent is here. What's interesting though is some of them are this color, some of them are that color. Why is that? That's another thing to figure out. So in terms of the detail you've yeah, we want to see what the T is like basically at that point. Hmm. Right, we're gonna do a couple of things. So we're gonna do this 6, whatever that is. Let's do v.t, okay. Here we go. So that's 0.18. So if we move slightly to the left, so that what we're looking at here is the geometry itself, the cement layer of the brick, if you will. Now we're on the now we're on the bubble, which is like far closer. Yeah. So maybe that's not right then. That would. No, I reckon it's something else. Oh, actually, no. Yeah. Because if you're already inside the sphere, it's a problem, isn't it? So maybe. Yeah, because this is the nearest. If the nearest negative, then you're inside it. So. Interesting. We could say if the far is greater. And then. Yeah, that shades the rest of them. Sort of. Pick up the. It's now looking a bit. Yes, you see him cut off there. Cool. So for these ones, so I think the ones which kind of go outside the grid. Wait, that shouldn't even be possible. I think that's part of the issue. That shouldn't even be possible because if they go outside the grid, then the offset is too big, I think. Yeah. So -1 to 1 max radius. But then Okay, so your cell is yeah, so if you're offsetting by, so what we're saying here is the minimum half dimensions of a cell is 3 times the max radius. So it's 1.5 spheres, right? And that's, so that means if we offset by a max radius, we can still fit another yeah, maybe it's a bit far, we just need 2. So interesting. Yeah, it's definitely bumping into this min radius thing here, actually. Oh, a minute. So max radius is 0.1. I see. Oh, wow. My performance ain't too bad there either. Yes, I think these numbers got to go smaller for these spheres, but interesting. Yeah, so maybe we've got to draw it to make it make sense. So we've got a box. So we've got a grid cell. We want the grid cell to be big enough such that a sphere with a random offset always fits within inside the box. So if we have it with a radius which is the maximum size could be well, yes, I think I did. So if you did 2 times radius, then you can offset by a radius, and then it could be a radius in size, right? And it still fit inside the box. But that's at most the offset would be, right? If it's so 2 times radius. That's the minimum size. So then let's have a look at its max radius some more. Oh, so W could actually be -1. This is where the problem is. So, oh no, it's unorm, isn't it? Oh crap. So it's not snorm, is it? Is there an unpack snorm? There is an unpack snorm, I think. So we want to snorm, and then this one will be convert to unorm. Okay. And then if we did far, okay, so we're seeing, yeah. So you could probably color them based on the grid index as well, or something like that. Another thing we could do. But yeah, we're seeing, yeah, they're randomized based on a seed. And the seed is probably the same. Yeah, we probably need to seed it based on the grid itself, kind of like the grid index and stuff like that, maybe. Because they're all looking kind of the same. But yeah, so the way we're sort of seeing it though is this bit isn't colored in because we're already inside the sphere when we hit the surface of the cube that we're trying to render. And but if we change it from near to far, such we say if the far of the shape, yeah, then it'll move the hit t back. But then it will kind of go have a negative t, I think, and go outside the shape. But those ones we probably won't accept anyway, due to some other reasons. Yeah, so why are those spheres allowed to go outside of the grid cell then? What's causing that to happen? Oh wait, this is a cell half dim. Yeah, the half dim is radius times 2. And that's fine. Okay. I think so. What happens if I offset it by a half radius? Does that fix the problem? Oh right, yeah, because the first one is actually outside of the volume, isn't it? I remember now. So because we've got well, we had it here earlier. So because our cell half dim, so the cells is sort of done from the center, and say if we have, so as soon as you've done a 2x2 and you made it a bit smaller, you've now got essentially a 4x4, if you will. What's the way of doing it? Yeah, so you got this sort of like 4x4, if you will, and kind of going up this way as well, blah, 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 blah. Then and obviously down here, then so what's happening is these spheres are sitting outside the material space of -1 to 1, right? So of course, when they sort of come into the reality of material space, we're getting ones which are like, yeah, so we want to somehow reject those spheres, which, but then are you just rejecting? Yeah, you want to reject the spheres which are actually a distance to the edge, which is less than their radius. Yep. So you want to do, you could probably do an SDF to a box, maybe, like check if they're, but you only really want to do that if, But yeah, I wonder though if it's, yeah. Yeah, I think you're doing SDF to the box. We've got one of those somewhere. So how cheap is it actually? It's quite a bit, isn't it, really? Or you could just do a reverse box. Is that a similar sort of thing? There's not any lengths here, so this would be better. So yeah, I think you do a reverse. Wait. Yeah, reverse box. So where would you do that though? So you can say only if I hit the sphere do I do this second check. It kind of sucks though. I have to do a second check. Yeah, so let's say, all right, we're about to accept this one. So we'll do a, so it's the sphere center position to sphere center position is what it would be. Redirection. And 1. And you get your result here. So you call this the material area here, call it an MH. So the near and the far, Yeah, that's not really what you want to do, I think, because it's limited to a specific direction, isn't it? Hmm. Yeah, it's probably not wires. Yeah, maybe the SDF will be it. But I think you can get away with a... That length hop kind of sucks. And maybe there's something else you can do. Right, so sphere center position. Half dims is just 1. Radius of 0. Then here's your sort of distance to the... If your distance is less than... is greater than the radius. So it's the edge distance. Material edge distance. Right, seems to have got rid of all of them, which kind of sucks, but I don't know if that's right. Maybe that's messed with performance a bit. Not too bad. Um, ooh. Right, so sphere, center position in the local space of material space. There's too many boxes now. So it's this guy. He's got a sphere somewhere. So you got a point. And you're going, how far away is it from here? Ah, it's always going to be negative. So we want to negate it. Because it will always be inside. No, wait, but it could be outside. Yeah, but it could be outside, right? If the point is outside, it is therefore yeah. So it's actually got to be less than negative. It's got to be less than negative radius. I think that's right. Maybe not. Hmm. Because you'll get a negative sign distance field to the edge of the box, right? So you need to make sure you can fit the whole sphere in there. Yeah, that's right. But this doesn't look right. Hmm. So it seems like these ones which were here, which got rejected, then just cut. No, I didn't necessarily cut. Okay, that's good. But why then does this sort of look like it's... I've got the full thing. I think this is progress. This is very skeptical up here. Very fizzy. Is that something weird is definitely going on? Maybe to do with the grid borders, maybe. Okay. So if we hit the T and VT. Yes, I think if we render the whole sphere, we might see it better. So there's an early reject here that goes on. If we get rid of that. Right, it's not really helped. Yeah, I think it could be to do with the stepping now. I think part of the problem is the stepping code, maybe. Because we're essentially, ray tracing through a grid, isn't it? There is the algorithm you can do like a DDA, but I just was doing it lazily with a Ray versus ABB, but I think it still has some problems. Potentially this is where the issue is lying now. But I don't know. So I'd like to know what this sphere center position is and the radius. So I'd like to know that. So we print those out. So that'll be, let's just print out a 10. So that'll be a vec4 sphere center position and a radius. Okay, so let's try this out. Oh, we got a hang on. Oh, it's done a break early. Right. Whoops. Ah, that's the problem. Using AI at work. Yep. I can neither confirm nor deny what we use at work. I think. I don't know what the policy is around on that. Yeah. I just think it's better if I just don't speak about work stuff when it comes to the tools that we use. I think not my place to speak. But how you doing, Kept Paying, anyways? I know you're quite a big fan of AI. Have you been using it for much? I typically just use AI to do Google searches. That's for me. Because Google sucks. And when I was young, right, back in my day, when I was first using the computer, Google searches used to be great. You used to search on the internet and the results would be kind of right there on the first few links. Then slowly things just started disappearing. And you never, yeah. Used to be as good. Yeah, sorry, it used to be so much better. That's not as good. Same with like YouTube, you search for a video, and then after 10 results, they say, you might also be interested in this. It's like, no, what I was interested in is my search filter. That's what I was looking for. But now you've just shown me a load of crap that I don't want to watch. Anyway. So yeah, AI is very helpful for finding stuff. And also kind of digesting extremely long papers and stuff like that. And then you can be like, give me the summary. Explain to me like I'm 5. Amazing. But obviously, it doesn't give you the 100% truth. So, but it's better than having to spend absolutely hours trying to find the truth, the absolute 100% truth. Right? Sometimes. Right? Sometimes you want to spend the absolute hundreds of hours to find the absolute truth. Right, so I think we're getting an improvement. Although it kind of looks fine on one side, but not another, which sucks. And that's probably nothing to do with... So this is cool, right? These are the spheres that we want. And then you can like drill in even more to them, right? It's amazing. So you can like, you know, drill into these and there'll be moss in there or something. It'll be cool. But then these ones. Big problemo. Probably because of the grid thing, isn't it? Or I don't know. And these, what are these? These are just pretty silly. What's that? Hmm. Yeah, looking a bit silly. So if I were to remove the edge thing, does this like... Right. So you see these fizzy ones here, they're still here. So they're caused by a different problem. Nothing too related to... Well, it sort of changes it a little bit. Weird. Maybe there's some kind of fudge factor, if you will. Right. Eh. Nope. Okay, so... Oh. Fair enough. No, I was just saying I probably shouldn't best answer what you know we do at work, but you know, personally I use AI just for searching on the internet because Google sucks these days. Put it that way. I use it for researching. I use it to quickly digest, you know, papers or stuff like that, you know. Or seeing different ideas if I'm stuck, basically. But I rarely use it. I more try to think first. No, it crashed. Yeah, this is a bit silly. You gonna stop? Okay, so Okay, so quite happy with these guys, I think. These ones, no. Could it be the fact that they're actually being shaded properly, but then discarded for some reason? No, it's not, because... Yeah, because some of them are spheres, some of them are hitting the thing. So there's the hit T, maybe it's something to do with the hit T. Yeah, I think it's to do with the hit T. So that's to do with... Yeah, we already tried this though, didn't we? Hmm. I wonder what the detail UV looks like. Where is it? Yeah, so I think we bring this one out. We put it here on the entry point. My concern. So you got -1 on the Z, 1 on the Y there, +1 on the X. Cool. So that's all right. You know, could it be to do with that? You know, I took this multiplied by 0.999 thing, but then no. So detail UV then. It works on one side, but not on the other. The tops, see this big one here that we're looking at is the top of one, isn't it? So like, then that means that yeah, this back edge looks really great, but this top one is a bit fizzy, right? We're seeing it here too. So something about, yeah, we've got to figure out something to do with the sides for some reason, what side it's on, which matters for some reason. We could be looking at these grid cells. Maybe some of them hit infinity. No, we don't need to do infinity, do we? Anymore, we changed that. Save, quantity break. I wonder if it's something to do with this. No, that's for sure. So I wonder if the bh dot y is less than or equal. Let's say negative, right? So if that's the case, can we break? Interesting. So what this is proving, right, so we are hitting some cases where the far is negative, so then it's just being dragged forward regardless. Maybe. Yep. That's bizarre. Yeah, so what's happening is we're being rounded into the wrong box, I think. The wrong grid cell. Something along those lines. I did a floor, didn't I? Maybe it was meant to be around? No. So, right, let's try a seal. How does that look? Yeah, some of this grid cells, I think. So, right, so what we can do is we can get those as these sort of separators. Then I think we can print out a lovely 3 and a 4, and the 4 would just be the cell center position. Then, so we should see a G1 and 2 in the print. Those would be separators. And then just a for loop of ray tracing through a grid cell. And we should see a repeat of 3s and 4s. 3s being the detail UV or the sample, the ray origin, the ray position as it's stepping through, and the center position to the cell as it's going through. So, okay, so these ones. Yeah, this is where we could probably debug draw a grid and that might just look better. But then, nah, because you'd be doing it per pixel. Not easy. So, yes, this one is the one that should be working, right? So the G4 ends up going like positive on the X a bit more to 0.6 and a negative on the, interesting, I did say floor, didn't I? Yeah, strange. Oh, because there's a plus 0.5 in there, isn't there? Yeah. So, that 0.5 should probably be applied along the. Yeah. So what you want is a direction. So that so you want an actual like ray direction thing normalized. So yeah, it's not already normalized because it's scaled. There's that. Anyway, this is gonna be. Yeah, I think he was looking for a sign. Maybe just looking for a sign. Yeah, maybe what you're looking for actually is -1 or 1, not no 0, so I got the underscore version. Ah, for crying out loud. Is it negative sign? No. Okay. Hmm. Then maybe that's not what we want. Maybe I need to draw it out quickly. So it could start actually back here, for instance. So if your ray eye going this way, you hit here, obviously. And then you want to try and, there's like a grid in here, right? So you want to, how's the code work again? Yes, you'd actually hit here, sorry. Then you'll be like, where's my center position in my cell? So it does like a divide by the cell dims. Floor it. Offset by 0.5. Yeah, no, that's probably right. Yeah, so maybe that's not the issue then. But why could it be a problem on top? Yes, you would like offset by 0.5 and get to the middle. So if you come from here, you got your ray eye up here, you're down, you hit this guy, and say if this is like grid cell. You would floor it to the corner, you would offset by half, right? And boom, got this guy. This is your center position. So I don't think that's an issue then. Maybe it's something else then. Hey, Avalanche pointer. Yeah, it wasn't bad. Yeah, it was quite good actually. Just relaxed. You know, church. And what else? Yes, hang around with family. Went around my parents. Went out to, sat in the sun. It's very nice and sunny. Had barbecue. No, sorry, not barbecue. Had a nice roast dinner with my parents. What else did I do? Yeah, took my boy out on his bike. Yeah, it was nice. How about yourself? Was it a good time? Yeah, obviously read lots of Bible as well. I managed to jam through John in a few days, which was cool. Yeah, super great. I also yeah, I went mostly through the Book of Enoch as well at some point. I think I got what I wanted out of that one. It's an interesting read. Also, I've been reading. Yeah. It's basically the Bible and Bible adjacent books. What I've been reading. But But yeah. Oh, and also went evangelism as well on Saturday. Yeah, do some evangelism. It was kind of cool. Although I had a bit of a sad story. There was a guy who a homeless guy I've been praying for, and it was really amazing because he was on the streets, and I was like, he's been to prison and all this, and he was heckling me one day. And, I just did the thing where entertained him for a bit, and he was saying, "Oh, do you like believe? You, surely you don't believe in stuff. How can God be real?" Anyway, I just I gave him the gospel. He said he used to be a Catholic, but I gave him the gospel. Prayed for him. Next time I see him, he's given his life to Christ. Completely changed man. Like you can see the Holy Spirit's dwelling in him, and turns out he got saved. Mother Church came and picked him up, and it was really great actually. But then recently I found out he's got some bad news that he's back on the streets again because just some bad things happened. Unfortunately, one thing led to another, and the enemy basically got him in a bad situation. So that's some bad news there. So I'm just praying for this one now. I'm at Judges in my first read forever. Cool. Easter was same-ish. Nice. Amazing. Yeah, Judges is quite an interesting book. Lots of good little stories in there. Yeah, I need to go over that one. I've only read it once. I remember a few bits from it though. Yeah, where you at now? So your Judges, then you'll be going into Samuel from there, wouldn't it? You see if I know my Bible enough. Oh no, Ruth. Right, of course. Yeah, Ruth. Ruth is a good book. It's also kind of yeah, an archetype of like a type of the Church in Christ as well. Pretty cool. Yeah, then Samuel, then Kings. Hey there, Mesticare. Welcome, sir. How are you? All right. So I think we made some reasonable progress today. There's spheres rendering on the surface of the thing, just to one side, not the others, which kind of sucks. Yeah, we need to sort this out next stream, and then we can go further into actually ray marching into these spheres. We probably want to change the frequency of these, make sure we can make them like proper dense and filled with spheres all over the place, and go between different modes of having it dense and not so dense, and still kind of see them based on these parameters here. And then when we have all that working, we can then ray trace or ray march into them, and there'll be a custom like material thing, like maybe a moss or grass or something like this. So yeah, it should be cool. I notice this, I'm not rendering on these sides here, but yeah. Right, so next stream will be on Thursday at 7:30 p.m. GMT +1. We can come and chat in the meantime on the Discord channel. And also, if you want to support the channel, you can get access to this code and run it on your own local machine by supporting via some membership on Ko-Fi. And thank you for everyone who's already doing that. To be honest, I don't know what you're creating first time open your stream. Yeah, it's a little custom engine basically. That's what we're doing. Little custom engine. Details on it. Well, there is a VOD channel. Is the right one? There is a YouTube channel basically. If you take my handle and pump that into YouTube, search Heroes Studios, put into YouTube, there's a video on demand. But if you come to like the next stream, I can give you more of a rundown in less time than looking through those, I think. But yeah, I have to go right now. But anyways, have a good Wednesday, guys. I'll see you on Thursday, and God bless you all. Have a good night. Bye bye.